Welcome to the Gladden Longevity Podcast with Dr. Jeffrey Gladden, where our passion is helping you to become an age hacker. On this show, we want to help you optimize your life energy, longevity, health, and human performance with impactful and actionable information by answering 4 questions. How good can we be? How do we make 100 the new 30? How do we live well beyond 120? And how do we live young for a lifetime? I'm Steve Ryder, and Dr. Gladden, we just wrapped up with Dr. Stephanie Venn Watson. And we spent a good chunk of time at the beginning talking about how dolphin health really opened up the doors and found this new essential fatty acid for humans.
Yeah, absolutely. It's one of the more fascinating conversations we've ever had, quite honestly. Yeah, she's a fascinating individual. We had a lot of fun, a lot of laughs on this show too. And yet we were uncovering some of the foundational pieces of longevity. I think this is one of the most foundational podcasts we've done in that regard. This whole concept of C15, this carbon 15 fatty acid, how it was discovered by the Navy, actually. Even that story in and of itself is fascinating, but how it's translated into human care, and then how it makes these dolphins live 50% longer and the impact it can have on humans that they're seeing in humans. It's amazing. And if you want to wipe out your fatty liver disease, you want to listen to this podcast. It's pretty it's enlightening. Yeah.
Absolutely. This is one I'm definitely going to be getting this supplement. Fatty 15. Yeah. If you go to fatty15, that's the number 15.com/Gladden, you'll get 15% off of your order. And I'm going to be buying this later today.
Yeah, absolutely. No, it's a total winner. This is a kind of a game-changing conversation. So super, super good stuff.
And for listeners, if you love what we are presenting, please be sure to click subscribe. And if possible, please share this with someone that you think this would benefit. I mean, like Dr. Gladden said, this is a big podcast for us. One that both of us were really excited and talking about, how as we have gone to non-fat dairy, which is a way in which we get C15 into our bodies, we've seen fatty liver.
We get it out of the fat and dairy, right? So when we go to non-fat, we're missing that piece. But even there, you only get a small amount. So really interesting story here. Yeah, you're going to love this, quite honestly. Welcome, everybody, to this edition of the Gladden Longevity Podcast. I'm your host, Dr. Jeffrey Gladden, and I'm here with Steve Ryder. Steve, we saw each other not long ago.
Yeah, just 2 hours ago with the last interview that we recorded. And but this is one I'm excited to learn about because I'm familiar with C8 MCT oil, but what's a C15?
Yeah, exactly. And everybody's familiar with omega-3s, but what's a C15? This is kind of the burning question. What the heck is the C15? So the person that's here to enlighten us on what is C15 is our third dolphin veterinarian of the week, Dr. Stephanie Venn Watson. Stephanie, welcome to the show.
Oh, thanks, Jeff. Great to be here.
Yeah, super. So bring us up to speed a little bit. How did you get to be a dolphin veterinarian? That's a niche position, I think, in the world, but a very cool one.
Yeah. Thanks. I actually, I wanted to be an epidemiologist chasing down infectious diseases. I had read The Coming Plague by Laurie Garrett, and I was sold. I'm like, I'm going to be in Africa and ready to hunt down Ebola. And then I was introduced to a veterinarian, interestingly, who said, gosh, if you want to understand disease, don't just study it in humans, study it in many different species. From a comparative perspective, sold on veterinarian. So I became a veterinary epidemiologist and worked for CDC, World Health Organization, for a number of years. And then about 20 years ago was recruited by the Navy to help.
Well, let me interrupt you before you get to the Navy. And that is, what were you finding in your epidemiologic research for the WHO about the animals of the world? What was popping up?
Yeah, so I ended up focusing on the very exciting world of diarrheal diseases.
Oh yeah, that is exciting, especially for habits.
But with regard to the focus of my work was on reptiles and salmonella, and most of the diseases, a lot of diseases we get from food is actually foodborne from animals, and so there was a lot of studies being done there. Doing outbreak investigations with regard to food. And, it was a really good job. And what was discouraging was every year we knew we were going to have this outbreak associated with visiting a farm or at the church, or just so repeatable. Was really excited to be able to apply epidemiology in a way that could be translated into actions, right? So that we didn't have those anymore.
And were you able to effectively do that?
Yeah, in a little bit. I mean, it was really the team. It was CDC.
No, I realize.
I was just a humble number cruncher in the sub basement at the CDC.
Yeah, I'm imagining you and Humphrey Bogart going down the river there in Africa, But okay, cool. Well, that's very cool. So then you joined the Navy. So what happened there?
Yeah, so I was recruited by the Navy to continually help improve the health and welfare of the Navy's dolphins. And I didn't even know that the Navy had dolphins at the time. And so they've cared for this population of about 100 bottlenose dolphins for over 60 years.
Wow.
They live in San Diego Bay, go out every day. It's a really amazing group of animals.
I understand they're highly trained, actually.
Yeah. They're really good at what they do. Yeah, being able to find lost objects and detect enemy swimmers.
Exactly. I was on a call. Well, actually, I was in Antigua researching a technology, and there was a woman on the team there from San Diego who likes to scuba dive. And she was talking about a professor at UCSD that liked to scuba dive, and he kept getting bumped by dolphins because he was trying to kind of sneak into the Navy SEAL area, and the dolphins kept coming out and banging him up, right? So that was the first I'd heard about the Navy trained dolphins, and that was just like 10 days ago. So anyway, pretty interesting. So you went there, and so then you became involved with the care of the dolphins. Is that the idea, or what happened?
That's right. So as a veterinary epidemiologist, or a veterinarian with an added epidemiology degree, they had me come in because, Jeff, they've taken such good care of this population that they had collected routine healthcare data on these dolphins throughout their lives for over 60 years. So it was this longitudinal database of CBC and Chem, right, just like you and I get, throughout their 35 to 50 year lives. Plus they had archived serum.
Fascinating.
Pretty valuable. And when it became even more valuable, it was because it would give us a chance to be able to look for rates, aging rates and changes over time among otherwise healthy animals. And so it was great. I was brought in to really help understand the health of aging Navy dolphins. They're living so well there that Navy dolphins live on average 50% longer than those in the wild. And they brought me in to help understand aging Navy dolphins and how to continually improve their health and welfare.
Well, that's interesting. So typically you'd think that animals in captivity would be living shorter life expectancies than ones that are out in the wild for the most part. But here the dolphins are living 50% longer than their wild counterparts. That's a little bit surprising, although it must imply that they're actually happy where they are, right? Because, you see animals in zoos and they all seem depressed, but these dolphins must like what they're doing if they're sort of thriving, I would think. What did you figure out about the dolphins and their aging process? What kind of things were you looking at, and what did you figure out about how they're aging?
Yeah, it's fascinating. We started understanding that as dolphins get older, they look a lot like us as we get older. So we had where dolphins could develop high cholesterol, chronic inflammation. They were getting fatty liver disease, and even the full suite of changes consistent with Alzheimer's. So
interesting.
All of a sudden, it went from me having this great gift of reaching out to the world's experts to help dolphins and in human health, because this overlap, to then people on the human health side going like, what? We have a natural large brain, long-lived mammal that over decades is developing our same diseases. It became really a mutual endeavor to help both humans and dolphins.
That's fascinating. So, a lot of Alzheimer's is believed to be have a combination of genetic predisposition. There are 3 genes for Alzheimer's that actually are big, heavy players, if you will, coupled with diet and environmental factors that seem to accelerate or decelerate the process. So I'm just curious, with these dolphins living longer, what was it about their environment / food intake that might have allowed them to live 50% longer? And I assume that they're not just living longer with dementia, but they're actually avoiding dementia and some of these other things more than the wild. I don't know. You tell me.
Yeah, so with a couple of things to unlock there. The first is that why are Navy dolphins living longer? And a lot of it has to do with care. I mean, it used to be, when you watch the wild animal, planet Earth and whatnot, that it was like, oh, the wild is great for animals. it's getting tough out there.
Yeah, it's
for
rough
wild
out there,
animals.
man. Yeah.
Right? Availability of food, oil spills,
Yeah.
loss of fisheries,
Yeah.
changes in the temperature of the water. So a lot of these things actually are making it harder for wild animals to, thrive. And the Navy dolphins, they get access to routine healthcare, control, they have food every day. They don't have to worry about being, have predators around. They don't have to compete against each other for the ladies, lady dolphins. So all of that helps really reduces a lot of the risk factors for dolphin mortality in the wild, resulting.
So do the male dolphins, do they fight like elk do or something in order to mate? Or is it a different, I'm not familiar with their courting mating construct.
Yeah, they're very promiscuous.
Yeah, that's
dolphins.
what I heard. Yeah, that's what I heard.
They have no problems, but they will. The males will compete, and they will get rough with each other in the wild.
Okay.
And they're very well behaved.
Yeah, they're very promiscuous, from what I understand, and they also, I think they're one of the animals that has sexual activity just for the fun of having sexual activity, not just procreation, right? And
yeah, that's right.
Yeah,
yep.
And they also have, the males have the largest testicles, I think, of any animal. They're massive, from what I understand.
That's evolution going to work there. So and the females are able to have babies for calves very far into they do become senescent eventually, but they can't have babies. And it's in part because the whole pod, fellow females, will actually start nursing to help support another mom's calf. So it's a strong, strong community structures. And most importantly, like for here, right, is that they're truly long-lived, large-brain mammals who have, evolved to have similar needs with regard to getting glucose to the brain and various things that are good, but can also lead to risk factors for diseases like dementia and diabetes.
So in the 60-year cohort, basically, have they just kind of lucked into a healthy diet? Did they try to replicate the diet in the wild, or did they get silly and start throwing pellets in the water, like they're feeding the fish?
Vitamins and supplements.
Tell us a little bit. Yeah, exactly. Tell us.
Yeah, well, that gets us That gets us back to C15. Is that they get a very well controlled fish diet, and every lot is measured and assessed. And so it really gave us the benefit of being able to understand if dolphin A ate more of a certain type of fish versus dolphin B. We were able to show that the diet, specific types of fish that the different dolphins were eating, because it's kind of like a buffet. They have some choices, right? But still limited. Dictated which dolphins were developing these aging-associated conditions and which weren't. And we did this advanced study called metabolomics to look at thousands of small molecules in their fish and their blood. And that's when we found about 100 molecules that predicted the healthiest aging dolphins. And among the top of those, Jeff and Steve, was C15. And so we discovered C15 as, here's a fatty acid, odd chain saturated fat in the dolphins that if higher in their fish and their bodies, they were less likely to develop these aging associated conditions.
That's fascinating. Now, did C15, let's say there's 100 molecules that contribute here. I'm just trying to give the audience a sense of the relative impact of C15. So was C15, did it account for 20% of the effect or 5% of the effect, or it probably wasn't 1% of the effect, or it wouldn't be number one, but was it 50% of the effect? How did you feel about that?
Yeah, it depended upon what we were looking at. So for example, we found, aging associated anemia, right? Anemia of aging. It's very common among people. A lot of people as they get older, as you know well. We were finding the same thing in dolphins, that a high prevalence of dolphins had anemia once they got old enough. And so we found that not only was C15 predictive of dolphins without anemia, when we gave them a diet that was higher, fish-based diet, higher in C15, the anemia in all of those dolphins resolved. There were other things that benefited. They also had lower cholesterol, lower inflammation, lower insulin. And so because of that noise that you're talking about, we then moved, because of the promise of C15, we then moved it into the lab to do 8 studies over 3 years to, really put C15 to the test.
Okay. So I'm still not sure what percentage of that effect out of the 100 molecules it had. Do you think it was 15 or 20%, or it's hard to say maybe?
A best way to put it is that the molecules were ranked using random forest regression into which were the most important for the dolphins, and C15 was number 1.
Okay.
So if they were ranked against each other, basically, in importance in having this positive effect.
The reason I'm asking, I suppose, is because I wonder if there might be a collection of 4 or 5 that would be like particularly helpful or something like that. Did you come away with any insights around that?
We have. In fact, that was the Navy came back with the exact same question. And so they said, gosh, C15 is off and running and looking great. It's probably not the only one, right? We have a lot of discoveries to make here.
Right.
So we've been funded by the Office of Naval Research, not only for that initial work, but also to work on molecules 2 through 7. So we've been busy working on those.
Okay. Can you name what those 2 through 7 are, or is it maybe hard to
Not quite yet.
Not quite yet. Okay. Got it. Okay. Well, let me ask you this. Are they things, here's the other thing. Well, 2 other questions. One, what's the lifespan of a dolphin in the wild versus what are we talking about here?
Sure. In the wild, they live on average to 20. Okay. Navies at the dolphin routinely live to 40 and even into their up to 50.
Okay. So that's massive impact. Yeah. And then, dolphins are mammals, obviously. So they're more similar to us than fish. I guess the question is, does the research point to the fact that C15 is helpful in humans as well? Have you tried it in other primates or mice or some other things? I'm sure you have, but I'm really fascinated to learn more. So.
Yeah, absolutely. So we had that same question. Okay. So while this was, it's been a 10-year journey of science. And so we made that initial discovery in the dolphins. And then we moved C15 into the lab. When we did that, it ended up that the same studies were happening in humans, those epidemiological ones, showing that people with higher levels of C15 were less likely, especially to have or develop type 2 diabetes, heart disease. You have specific interest in. And this includes a lower risk of heart failure, especially coronary heart disease, and even factors related to cardiovascular disease of lower cholesterol and blood pressure. So there was a concurrent trend being detected in both the Navy dolphins and humans at the same time, which is really
that's fascinating. So people were actually measuring C15 in humans simultaneously is what you're saying.
They were. And interestingly, C15 has been used for a long time as a biomarker of how much dairy fat we eat. So dolphins' primary source of C15 comes from fish, which is primarily in the skin and the heads, which we don't tend to eat. For dolphins, for us, for sure, by far, our primary source of C15 is dairy fat. And so it's so good. And exactly.
So dairy fat. So we're talking like ghee and butter and
milk, yogurt.
Yeah, but more like whole milk and creams. Is that what we're talking about for C15?
Exactly. Yeah. So when you look at it's everything that's whole fat. So whole fat milk, Steve, exactly what you just said with regard to the yogurts, Jeff, with regard to butter, ghee, all of those things have C15, but important to note that even the highest, like whole fat milk, has 1% of the fatty acids in whole fat milk is C15.
Okay.
This born and raised cheesehead is loving what's being talked about.
Okay, that's right. Okay, nice effects there. Too bad about the Packers. So the thing is, with C15, I'm sure that somebody's put it in a capsule, right?
We have, yes, we have. So but only after many, many years of studies. This is, discovery was made while I was at the Navy. So it's a Navy technology. And so all of, as far as with regard to what has come from there is all thanks to work at the Navy. Yeah. So from there, so basically we worked with pure free fatty acids, C15, in the lab. And that's where the goal, right, was to say, can it have a positive effect on its own? And can we figure out, if it does, how does it work? Right? That makes sense.
Sure.
So we look at mechanisms of action. This will be familiar territory for longevity. And we and others discovered that C15 is an AMPK activator, an mTOR inhibitor, and activates PPAR alpha delta, and also inhibits JAK-STAT and HDAC6. So we talk about promiscuous, right? This is a promiscuous fat that really likes to, it is doing a lot for being a really simple molecule.
So most molecules are a bit promiscuous.
This episode of the Gladden Longevity Podcast is brought to you by the new Gladden Longevity blood vessel formula. The Mediterranean diet is often associated with heart health and longevity, and while red wine is often highlighted, it's actually the herbs traditionally used in this diet where the real magic is.
And Mediterranean herbs such as summer savory, basil, rosemary, and tarragon contain potent antioxidants that have been found to inhibit something called RNOx activity. And RNOx is a major promoter of oxidative stress in the arterial wall, which causes the arteries to age, increases blood pressure, decreases sexual function, etc.
I love that this formula has summer savory because I've never seen it in the fresh herbs section at any of my local grocery stores, even the health ones like Natural Grocers. And to get these benefits in a tincture, brilliant, Dr. Gladden.
Well, I'll tell you, I've heard from our clients and from my own use of it that they love it as well. You know, I just take a few drops or a dropper full and put it in my tea. It is alcohol-based. Tincture is the nutrients are extracted with ethyl alcohol. I drop it in my tea, it tastes good, or I drop it in water, it tastes good. And it's so nice to know that you're getting those health benefits to keep your arteries young. We love it.
Get 10% off your order of the new Gladden Longevity blood vessel formula when you use the code podcast10 at gladdenlongevityshop.com. That's podcast10 at checkout when you visit gladdenlongevityshop.com.
If you want to live young for a lifetime, keeping your blood vessels healthy is key. So check out the new Gladden Longevity blood vessel formula to assist you in your quest to make 100 the new 30. So let's just kind of walk that through for people. You know, the AMPK activation, of course, is key in terms of activating sirtuins and DNA repair and activating FOXO4, FOXO3, that actually has impacts on longevity and cellular health, if you will. mTOR is our friend part of the time, but our enemy part of the time too. So we like mTOR for bone density and muscle mass, but we need to suppress it to mitigate cancer risk and slow down the aging process. And that's a teeter-totter between mTOR and AMPK. When one activated, the other one isn't, right? So the autophagy also goes up when you inhibit mTOR and activate AMPK, which is also important. So that's very, very cool. What was the next thing you brought up?
We did PPAR alpha delta.
PPAR alpha delta. Okay, so this is related to mitochondrial function, I believe, and mitochondrial PGC1 alpha activation and mitochondrial biogenesis, right, comes out of this. So this is how one of the ways in which you're renewing your mitochondria, which is, of course, if you don't have enough energy to carry on the work of the body, everything goes downhill. And then the last one, the JAK-STAT, and there was one other.
HDAC6 inhibitors.
Yeah, I'm not as familiar with HDAC6 inhibitors. You want to talk to us a little bit about the last two?
Sure. So JAK-STAT is you can starting to see it on commercials for autoimmune diseases. A lot of these, injectables for autoimmune diseases are JAK-STAT inhibitors. Really exciting area for therapeutic research, inflammation, autoimmune diseases, and cancer. And that's where HDAC6 comes in as well. HDAC6 is also a key mechanism that's being chased for anti-cancer drugs. So interestingly, a separate group has found, looking at mice and cell lines, that C15 has really potent anti-cancer activities in early studies in the lab, just to make sure that that's clear.
Yeah.
Right. With regard to helping make gemcitabine, paclitaxel, common cancer drugs work better, as well as having their own effect. So excited to see where that heads in the years to come.
Yeah, absolutely. I was in conversations with a guy that developed a peptide to inhibit JAK-STAT, I don't know, maybe 8 years ago. to decrease inflammation, and they were treating people with autoimmune diseases and things like that with it and getting some nice results. So yeah, that's fascinating. That's really fascinating. So where do we stand with C15? Is it something that obviously we can eat some fatty dairy products? I will tell you this, if I eat ghee and butter, my cholesterol goes through the roof. So right. So I need more than 1%, right, to bite that bullet. So are there other places to get it? Can we get it from fish like they do?
We can. It's hard. It's hard to get because again, it's in the skin and head, and so maybe if we did all anchovies or
I love sardines with the skin on, and
sardines, that will be a better source than just fish fillets. But a big reason why we cooperated with the Navy to develop a pure C15 supplement, a pure free fatty acid, bioavailable, vegan-friendly C15 supplement, is to get around this issue with regard to butterfat and milk fat.
Right.
So, and as you know, like that same thing that you're experiencing with high cholesterol, it has only 1% of this good C15. It has over 40% of the pro-inflammatory, even chain saturated fats. So it's like putting David versus Goliath in an unfair situation. So if we just have just the good fat, that's really enabling, a lot of success. And all the studies, importantly, experimental studies with C15 are all with that pure free fatty acid ingredient.
It still leads me to ask the question, though, out of the 100 molecules, and you're looking at the next 5 or 7 or whatever it is, whether or not some of those things in combination kind of move things in the right direction. Instead of handicapping it, it actually accelerates the goodness of C15. Do you have any, you don't have to share, you don't have to disclose anything you can't disclose, but I'm just curious, is that true that some of those combinations are actually helpful, or we don't know that yet?
We do, with regard to one of them that I can talk about, and it ends up being related. So when we looked at the top 5 of these molecules from dolphins, there was C15 on the top. Mm-hmm. There was a second one called pentadecanoic carnitine, which we're using PDC because it's a mouthful. So this molecule was second and third, depending upon the study. So we said, this is the next logical one to look at. It ends up that pentadecanoic carnitine is a metabolite of C15, where basically our bodies take in C15, it adds a carnitine to it, the fancy name for C15's pentadecanoic acid. So you combine the C15 with a carnitine, and that creates this thing called an acylcarnitine. We published this work in Scientific Reports in 2022, and fascinating molecule. While C15 is doing all these great things, and we haven't talked about it, but C15, we wrote this paper in 2020, published it in Scientific Reports, that C15 is meeting all the criteria of being an essential fatty acid. So the first to be discovered in 90 years.
Wow.
So, right? So it's like, it is a super special molecule that our bodies need, but we can't make. So C15, the pentadecanoic carnitine PDC, has its own amazingness, in which when we tested it in the lab and threw it against a bunch of receptors, we found that it's the second ever discovered full-acting endocannabinoid. So it's actually triggering both CB1 and CB2 receptors in our brain as potently as only one other endocannabinoid discovered.
That's so cool.
So sleep and pain and calmness, we understand we can get that now, even just by taking C15 increases PDC levels. Okay.
Yeah, I was going to ask you, it sounds like the body would make it. I would imagine also that maybe genetically some people are more prone to make higher levels of the pentadecanoic L-carnitine than other individuals. Is that true too?
Oh, I bet. Yeah. I bet it is. Okay. Yeah, I'd place a heavy amount on that bet.
Okay, got it. Yeah, very, very cool. So in that case, it's actually a metabolite of the C15. So it makes you wonder if taking the two together would actually be advantageous or disadvantageous, right? Because sometimes you take something, you shut down your ability to do what you should be doing for yourself, right? Like tie your own shoes. So,
Yeah, we're just starting to do studies with PDC, and we're finding it's encouraging, but nature's done a pretty good job at saying, hey, just get me the C15, get me this essential fat. Yeah. And I'll take care of the rest. But the big question, Jeff, that you brought up was, if you have something genetically that is keeping you from making as much PDC as you should, is there a way that we can find to be able to supplement that?
Yeah, no, that makes perfect sense. Okay, good. So is C15 available to the public at this point in time, or is it tied up in the Navy somewhere?
It is. So as we developed this supplement, and so it's available as Fatty 15 at fatty15.com. And it's been a great journey. We initially were planning to move this forward as a drug. We were looking at fatty liver disease, a lot of fascinating work being done with fatty liver disease as an aging accelerated disease, and C15 being able to intervene and stop with that. So yeah,
So let's talk about the age. In terms of, were you able to see any kind of elements of age reversal, like improved mitochondrial function or lengthening telomeres or improved DNA methylation ages or rates of aging or, anything like that, better proteostasis, anything that you could kind of measure and see that it actually improved when you're using this?
Yeah, absolutely. So it's been really exciting. So on that front, with regard to these different hallmarks of aging and markers of aging, that we were able to show that C15 repairs mitochondrial function. Okay. So we took impaired mitochondria and were able to reduce reactive oxygen species production by them, get those mitochondria back up and functioning. It strengthens cells. And so a really big part of C15's role, which is really unique in the longevity space, is that C15, it's a sturdy fat. And, when we talk about omega-3s and polyunsaturated fatty acids, these are unstable fats. So susceptible to oxidation, aging and oxidation go hand in hand. C15 is a really stable fat that doesn't get oxidized. So it goes into our cell membranes and it physically stabilizes our cells against breakdown, lower systemic lipid peroxidation levels. Wow. And there's even this really cool theory of aging and longevity that came from A.J. Holbert in Australia. And it's called the cell membrane pacemaker theory of aging. And he showed that the stronger the cell membranes, the more saturated the fats in the cell membranes, the longer a mammalian species lifespan was. So it's a secret. Yeah, really cool tap into, how mammals can live longer, just strengthen our cells.
Well, it makes me want to ask the question, if we're measuring C15 in a human, should we be measuring it in the red blood cell membrane? Is that the way to measure it?
Yeah, that is spot on. You can measure it in the serum and plasma, but the red blood cell membrane you get so much out of that. And that's because, one, it's more of a longer term understanding of your C15 status. Right. The other is, you can actually also take those red blood cells and you can test them for osmotic fragility test to actually see how strong they are.
Yeah, exactly. That's right. Stress them.
Right?
Yeah.
And, talking about the anemia picture, where C15 is effectively stabilizing cells, to red blood cells, to the point where it's fixing anemia.
So it's basically, because the red cells are sturdier, if you're listening to this, then basically the rate of production can catch up to the rate of destruction, and you can put the balance back into the equilibrium where you're no longer anemic. And so this idea of fats residing in cell membranes and testing things in the cell membranes has become important. Like when we measure magnesium or some other things, we can look at levels in the serum, but we can also look at it in cell membranes. And this idea of cell membranes being sturdy, that's really fascinating, because I wonder, there's almost a couple things going on there. One is, if you're improving mitochondrial function, and this is structurally strengthening the membrane, then the mitochondria is allowing the ATP to be able for the cell to actually, reinforce the membrane, right, and maintain the integrity of that. That's interesting. And then just for the audience too, what she was talking about with this osmotic stressing, right, it's basically, if you put a cell into a solution that is the same amount of, let's call salinity as your blood, then it's just normal. But if you basically change that salinity, let's say you drop it into water, then the water is going to rush into that cell and try to blow it up, right? So then you could measure how sturdy is the cell when it's under this stress of trying to be exploded, essentially by water rushing in to equilibrate the ion balance between those two areas. So hopefully that made sense to you. But the idea is that we do have tests to be able to measure this. And that's really intriguing. So let me ask you this. How much C15 do you take every day?
I take 200 milligrams a day. We recommend, each capsule is 100 milligrams. Mm-hmm. And so on average, every 100 milligrams we eat, there have been extensive bioavailability and PK studies on this, that for every 100 milligrams that you eat, you raise your blood levels by 10 micromolars. And so what's been wonderful is that all the studies, whether they're cell-based, epidemiological, or clinical trials, they all support a sweet spot for C15, which in our bodies, more likely than not, Jeff, this is going to be defined as this is the threshold of which you have below that, you have C15 nutritional deficiencies.
Right.
So this is for folks going to their doctor, it's a 5 microgram per milliliter measurement.
So this is important because we can define deficiencies, and at which point there are symptoms or signs that occur because of the deficiency. And then there's typically kind of a normal range and an optimal range. So there's probably a range here at which you're kind of okay, but there's probably another range at which you're robust, right? And so what would the range be where you're actually robust with this?
I'd say it's between this, if we talk about the micromolar level, that's between 20 and 50.
Okay. So that's a lot more than 5.
Yeah, so you've got a lot of room. To work.
Right.
Mm-hmm. And it depends on what you're looking at. If you look at studies looking at cardiovascular disease, there is an endless, from where they studied it, an endless linear relationship between the more C15 you have, the lower risk you have of developing heart disease.
Wow. When you say heart disease, we're talking about ischemic heart disease, or are we talking about cardiomyopathy, or what are we referring to here?
A lot of it has to do with coronary
artery
heart
disease. Mm-hmm.
Yeah, exactly. And heart failure, there have been meta-analyses on heart failure. So those are the main ones.
Let me ask you this. Have they done anything that's looked at people that do have coronary artery disease or heart failure, and if they replete their C15, that there's clinical improvement in the status of either of those?
That intervention hasn't happened yet. However, a clinical trial was just published a month or so ago at the end of November of 2023. And that was with C15. They took women who were diagnosed with fatty liver disease and were overweight. They put them on a caloric restricted diet of 1,000 to 1,500 calories per day, plus a Mediterranean diet. That was group 2. Low calorie, and the third group was the first 2 things plus C15 supplementation. And they all had improvements because you take down your calories, you're going to see improvement. Mediterranean diet, you're going to see improvements. Right. The third group had, above and beyond all of the other benefits, also saw lower LDL cholesterol. So we'll be in a handful of other things that we could talk about. But interesting with regard to the heart health picture, knowing that the highest risk of death for people with fatty liver disease is heart disease.
Right.
So it was interesting to see that those cholesterol levels go down.
Does it have an impact on fatty liver?
It does. Yeah. So in fact, so much so. So we first detected fatty liver disease in the dolphins in 2012, published a paper in the very popular Journal of Wildlife Diseases.
Okay. I read it every week. I don't know why. Steve has it.
You probably have it right in front of you, the latest issue. For us, that was a big deal.
Right.
And so we published it, and then I got a call or an email from Dr. Jeffrey Schwimmer, who's one of the top pediatric gastroenterologists, expert in children's fatty liver. He opened the first fatty liver disease clinic for kids in the world. So Jeff reached out to me and he's like, you're calling it fatty liver disease, but it's probably not the same. So we sent him a couple dozen slides of dolphin livers, and he came back with an email that said, we are a go. He's like, this is the exact same disease.
Same disease, yeah. Interesting.
He's like, and it's not because of sugar, because dolphins don't. It's not because of ultra processed foods,
right?
So long story short, over the past 10 years, Jeff Schwimmer, other Jeff, and I have been working in parallel but independently, where he's been looking at kids. We've been looking in this whole other world.
Right.
But he's been able to show higher C15 in children is inversely associated with the fat in their liver, or more C15, less liver fat. He just finished a clinical trial with C15 supplementation relevant to fatty liver disease. And I can't share the results, but they'll be out this year.
Okay.
And it's really exciting.
Okay.
In models in the lab, we have been able to show that C15 decreases all the components and even the pathophysiology of fatty liver disease. Yeah. And so together, it all supports that fatty liver disease is actually a C15 nutritional deficiency syndrome.
Oh, wow. What a fascinating thing.
Yeah.
You know what's interesting about this, Stephanie, is that we have treated some fatty liver. We're not, we're a longevity clinic and people come to us with many things. We're not just here for fatty liver, but we have people that come with fatty liver, of course. And we've had good success with them increasing AMPK, right? So if we increase AMPK, we had a guy that was told he was going to be on our transplant list. His liver was so bad. And he actually, when he went back 3 months later to his gastroenterologist and they repeated the ultrasound, his liver was normal, just from activating AMPK. So I can imagine that if we're using C9 or C15 rather to do this and it's activating AMPK, that may be part of the mechanism here, but it's interesting. Yeah.
It's pretty fascinating. So we're obviously, everything we've done is pointed to this hypothesis. Nothing has steered us away from it. So, it's so many people getting fatty liver disease now, 1 in 3 people globally now. And where did it just showed up, right? Like 1980, that was the first time it was, and now it's 1 in 3 people. So what happened concurrently? It's the same time we were taking C15 out of our diets. So we had moved from full fat to non-fat, and it's just like,
we could run a clinical trial on it here, actually, if you want. So, yeah.
That would be great.
Yeah, we could do that. We have a whole research team. So, Steve?
Stephanie, these dolphins, they're not eating the standard American diet and they're eating fish. How are they developing fatty liver eating the same diet as they get older?
Yeah, so it's a great question. So what we found was the dolphins have access to 5 different types of fish. So some dolphins ate a whole lot more of a fish type called capelin. And they're these little fish that don't have a lot of fat in them. And those dolphins had lower C15 in them. They were eating less C15 in their diet. And as a result, looking to this, starts this whole pathophysiology with regard to more fragile cells. It feeds into this process of fatty liver disease. And we're fixing it. The nice thing is that we're fixing it, right? So we're getting C15 back in your diet. Mm-hmm.
Very, very cool. Well, this has been a fascinating conversation, really fascinating. So where can people find fatty 15? They just Google fatty 15 and there it is, or what happens?
Yeah, it just pops up. Yeah, easy, fatty15.com.
That's the number 15.
Right. That's right. That's right. Thank you. That you can go there. And then all the science on C15 is at discoverc15.com. And that's where we put all the peer-reviewed publications. It is now far beyond us. It was been great to be part of igniting the movement, but oh boy, everyone's working on C15 now, which is been just wonderful to see.
Love it. Love it. Great. I'd love to do a study on this, and we can start using it for sure, right? Because it sounds like everybody would benefit from it. You probably never come across a C15 allergy, I'm guessing. So,
no, it happens. Right. And again, and the way we make it too is it's allergen free.
Okay, got it. All right, cool. Steve, any last questions from you?
No, this was fascinating. I've definitely added this to the list of supplements that I want to add to my regular routine.
Exactly.
To my regular routine. And definitely am going to be adding another glass of milk to my regular daily.
There you go. That's great. That's great. And half of our customers feel benefits within 2 weeks.
Okay.
I think in part because of that PDC metabolite. Like I know I immediately install sleep better, calmer mood, less joint pain. Oh, nice. And that's probably due to that metabolite.
Yeah, nice. That's really awesome. Well, cool. Well, thank you so much for being with us. Appreciate it. Yeah, thanks.
Oh, it's great being here. Thanks for the conversation.
Yeah, fun.
Thank you for listening to this week's episode of the Gladden Longevity Podcast. If you would like more information on what we've discussed or other topics, please reference the show notes or go to gladdenlongevitypodcast.com. You can also find us on Instagram, Facebook, and Twitter by searching Gladden Longevity. If you've enjoyed this podcast, please subscribe to get future episodes delivered to you and share our podcast or this episode with someone in your life that you may find benefit. Thank you for listening. We'll be back next week with another exciting episode. The Gladden Longevity Podcast is provided for informational purposes only. It does not constitute medical advice. This content is not intended to be a substitute for professional medical advice, diagnosis, or treatment. Always seek the advice of a physician or other qualified health provider with any questions you may have regarding a medical condition. The use of any information and materials linked to this podcast is at the listener's own risk.